A landscaper wants to plan a bordered rectangular garden area in a yard. Because she currently has 200 feet of border materials, the perimeter needs to be, at most, 200 feet. She thinks the garden will look best if the length is at least 10 more feet than the width. A. Write a system of inequalities to describe the situation. B. Solve the system by graphing. And then C. Give a combination of length and width that satisfy the requirements for the garden. We need to come up with our system of inequalities. And since we're working with a real-world situation here, we're going to be building a rectangle. The length and the width of a rectangle cannot be negative values. So two quick inequalities that we can come up with are that length has to be greater than 0, and also width must be greater than 0. We're also told in the problem that this is a rectangular garden. And remember that perimeter of a rectangle is found by taking 2 times the length plus 2 times the width. And it says in our problem that our perimeter must not exceed 200 feet. So 2 times the length plus 2 times the width must be less than or equal to 200 feet. We're also told in the problem that she thinks this would look best if the length is at least 10 more feet than the width. So length must be at least greater than or equal to 10 feet more than the width. So width plus 10, W plus 10, or our length is at least or greater than or equal to our width plus 10 feet. So there's our system of inequalities that we need to graph, and then we'll find the overlapping region where all of these overlap to come up with a solution to our situation. The first two inequalities, L being greater than 0, W being greater than 0, that strictly puts us in the first quadrant. So that's what I have here as a grid. And then we'll go ahead and graph these two inequalities and shade above the line or below the line to see if we have any overlapping regions. I'm going to take the top equation, the 2L plus 2W less than or equal to 200, and we can divide everything by positive 2 to make it a little easier to work with. That would give us an L plus W is less than or equal to, dividing everything by 2, 100. So we have L plus W less than or equal to 100. So 2 points that we can get really, really quick here with this inequality. If I let L be 0 and W be 100, that would make the left side equal the right side, or also vice versa if we let L be 100 and W be 0. So 0 comma 100 and also 100 comma 0 would both satisfy this equation. So we'll plot those 2 points, 0 comma 100 and 100 comma 0, find our intercepts, and we'll go ahead and draw that solid line because it's a less than or equal to situation. And we want to shade below the line. Shade below the line. Our next inequality is L greater than or equal to W plus 10. And let's come up with 2 points that would satisfy this inequality. If I let W be 10 and L be 20, that would cause this inequality to make a true statement. So the point 20 comma 10 is located where? 20 comma 10 right here. Let's do that in a different color. 2010. And also if I let W be 30, 30 plus 10 is 40. So the point 40 comma 30. There's also a point that would be on this graph, 40 comma 30 right here. And we have 2 points. We know it's a linear inequality. So we'll draw the line through those 2 points. It's a solid line again. And I would like to shade So choosing a test point and replacing those values into this inequality, we will see that we're going to be shading below the red line. Therefore, the area where both inequalities are true at the same time is this rectangle, this triangle located right here. So that area would be the graph of our solution set, which is what part B is after. And part C then is asking us to come up with any point actually in this yellow triangle that satisfies our situation. So as long as you choose any point inside the yellow triangle, that would be a correct answer to part C. So one in particular would be 60, 20. 60, 20 should be located right here. So that is one of other correct answers for part C.